Hello everyone, welcome back once again to our physics class. Today we are going to start this new chapter, chapter number 9. We call it as ray optics and optical instruments. In this chapter, this optics, this word, it is a branch of physics that deals with the study of light. It is a branch of physics that deals with the study of light. Under this topic, optics, you will be learning in class 12 in 3 parts, that is ray optics, wave optics and quantum optics. This chapter, chapter 9 that we are talking about, is about geometrical optics, in which you will have to consider light in the form of straight path. Light travels in a straight path because it has rectilinear propagation of light. So the assumption that to be made while studying ray optics is light travels in a straight path. The second assumption, you follow the laws of reflection. And the third assumption, you will follow the laws of refraction. And the fourth option, you will consider each light rays. Suppose 2 light rays are passing like this. They are independent of each other. They do not depend on each other. Both light rays, we will have to treat them individually. Light rays are independent of each other. These are the basic assumptions that you have to take. Now let us talk about light. Light, when we define, basically we define like this: light is a form of energy which enables us in the sensation of sight. Because of the presence of light, we can see things in and around us. You can even define in a more better way that light is a form of electromagnetic wave as well. When we say electromagnetic wave, you might have learned in smaller classes, those waves which can travel through solid, liquid and gases, as well as they can travel through vacuum. And light alone is not an electromagnetic wave. Along with it, 6 more are there together. Let me write down here. Gamma rays, they are also electromagnetic in nature. X-rays, ultraviolet rays, then you have visible rays, then you have infrared rays, then you have radio waves, and you have micro waves. These 7 of them together forms an electromagnetic spectrum. 1, 2, 3, 4, 5, 6, 7. And we are studying these visible rays that we call it as light. Light can exhibit dual character. They can exhibit in the form of wave also. They can exhibit as a particle as well. So when you study wave optics, you treat light in the form of waves. And when you study quantum optics, that is in chapter 11, the name of the chapter will be in the form of dual nature of matter and radiation. Little bit you will study about light in the form of particles. Quantum means very small. In the form of particles. Each particles of light we call them as photons, and each photon has a definite amount of energy in them. Later on we will study in detail in chapter 11. So light belongs to which part of the electromagnetic wave? The visible part of the electromagnetic wave. But when we take sunlight, then you have in sunlight ultraviolet as well as you have infrared radiations. These infrared rays helps us for heating up of the objects, and ultraviolet rays, most of them are reflected by the ozone layer, some of them are absorbed by it, and mine dose comes and reaches to our earth. That is the reason why we dry our clothes in the sunshine. It's advisable to dry up in sunshine so that the microbes can get killed. Now let us talk about this visible rays, about light. Visible rays, it comes as V, I, B, G, Y, O, R. These 7 colors: violet, indigo, blue, green, yellow, orange and red. And the wavelength lies in the range 400 nanometers to 700 nanometers. So in this range, with the wavelength we indicate with lambda. This is for violet light and this is for red light. So in this range we call it as visible light, from 400 nanometers to 700 nanometers. Now nano indicates 10 to the power minus 9 meter. That is equal to 4 into 10 to the power minus 9 plus 2. This is minus 7 meter. Likewise here also it is 7 into 10 to the power minus 7 meter. This is in terms of meter in our SI unit. So in this range we call it as visible light that we can see. Beyond this violet range, if the wavelength is lesser than this value, then that light we call it as ultraviolet light. This one, ultraviolet light. And above this wavelength range, that is 7 to 10 to the power minus 7 meter, we call it as infrared light. We human beings are not able to visualize these two. We cannot visualize these two, ultraviolet and infrared part of the light. In this chapter, that is ray optics, or we call it as geometrical optics, we are going to study these few things. First is reflection of light. The second one you are going to study is about refraction of light. The third one we are going to study about scattering of light. And then fourthly we are going to study about dispersion of light. These 4 phenomena, we call it as phenomena as well. We study under this geometrical optics, what we call it as ray optics here. But now due to this pandemic, some portion of your syllabus is reduced. So these two, reflection of light and scattering of light, is eliminated out from your syllabus. So we'll discuss from refraction of light. Then we'll study about dispersion of light. Now to start, refraction of light. To understand this refraction of light, you'll have to know about optical medium first of all. Now optical medium, these are of 2 types. They are classified as rare or optically rare medium and optically denser medium. Here denser and rarer does not mean which one is heavy and which one is light. We don't say this way, like our mechanics density is mass per unit volume. If I say whose density is more, iron or paper, then generally you say iron is more heavier than paper, or density of iron is more than paper. But in this case, the meaning is somewhat different. Here it says that if light travels faster in a medium, that medium is taken as rarer medium. Now, for optical medium, in this case, rarer medium, speed of light is more. Speed of light is more. Then that medium will be called as optically rarer medium. The same way when we talk about denser medium, in this medium, speed of light is less. Light is less in comparison to the other medium. So whenever two medium comes, in which medium the speed of light is more, that medium is called rarer medium, and in which medium the speed of light is less, that medium we call it as denser medium. Now this concept you have to keep in mind while studying about refraction. Now let us see what is refraction of. Refraction is a phenomenon of bending of light rays when it passes from one optical medium to another optical medium. Suppose, let us say that you have kept one glass piece here. This is your glass piece and this is air. Throughout the whole discussion, the rare medium I will be taking as 1, I will mark it as number 1, and denser medium I will mark it as 2. So whenever you see these numbers, 1 means you should think that it's rare medium, speed of light is more, and 2, that is sir is talking about denser medium, the speed of light is less. So whenever light passes, suppose there is a source, from there a ray is incident on the interface XY. Interface is the line segment that separates the two medium. Suppose this XY is the line or the surface of the glass that is separating the two medium. And whenever light travels from one medium to another medium, it should either reflect this way, refract this way, that is, it has to bend and go, or it can even bend this way also towards the normal, or it can go away from the normal. So this phenomena of light, we call it as refraction of light. It's coming from A to B, and either way, suppose it is going BC this direction, or it is going BC dash, let it be. Now I'll tell you when it bends away from the normal and when it bends towards the normal. But when you study about the phenomena, then it can go either of the way. Think in the beginning that this bending of light, either like this or like this, we call it as refraction of light. But you must be very sure that the two medium, it is in two medium. In one medium alone, refraction cannot take place. A minimum you require two media. Now again, from glass to air also it can go the same way. It will bend and go away or towards the normal. Now let us see what happens when light passes from rare medium to denser medium. When light travels from rare medium to denser medium, initially it was coming with high speed because it's rare medium, the speed of light is more. Suddenly, when it enters glass, the speed falls down. So if it falls down, then you should know that it will bend towards the normal. So it will bend this way. It will come towards the normal. Instead of going straight, it will go towards the normal. And reverse way, when light comes from glass to air, suppose air I am taking here, this is first medium rarer. Suddenly when light comes from glass to air, then it will go away from the normal. It will not go straight, it will not come towards the normal, it will go away from the normal. So these two things you have to keep in mind. When light travels from rarer medium to denser medium, it always bends towards the normal, and when light travels from denser medium to rarer medium, it goes away from the normal. As you already know what is normal, then every one of you will be knowing. Normal is a line that is drawn perpendicular with the interface or with the surface. If I am taking this as glass, this is the interface XY, or we call it the surface of the glass XY. In the same way, where it comes and strikes here, the refracted ray here, then this normal you will draw at that point, and this will be always perpendicular. Now some terms you have to know here. Now if I take one at a time, this way if I take light traveling from air to glass, so we are taking this glass. Then as you know that the ray of light will bend towards the normal, the angle made by this incident ray, this is your incident ray, with the normal we call it as angle of incidence, and the refracted ray and the normal, they will also make one angle here. That angle is called the angle of refraction. We write it as R. So when light travels from air to glass or from rarer to denser medium, angle of incidence always will be bigger than the angle of refraction. It will be always bigger. But in the other case, when light travels from say denser medium to rarer medium, if a ray of light happens to incident this way AB, and if you draw one normal at the surface, this is your surface XY, then from denser to rarer, if it comes, it goes away from the normal, and in that case angle of incidence becomes smaller than the angle of refraction. Here angle of incidence is less than the angle of refraction. So the terms here used are incident ray, refracted ray. Suppose VC is the refracted ray. The perpendicular line drawn at the point of incidence is called the normal. This one is perpendicular. The angle made by the incident ray with the normal is called angle of incidence, and the angle made between the refracted ray and the normal, we call it as angle of refraction. We write this R. Now let us see the laws of refraction of light. There are two laws of refraction. The first one, the incident ray, this one, the incident ray, the normal at the point of incidence, and the refracted ray all lie in one plane. You can see very clearly that my blackboard is the plane. All of them are lying on the board itself. It is always in one plane. The meaning what it wants to say is the incident ray, where it comes and strikes the surface, from that point only the refraction should take place. It should not be like the ray is coming and striking at this point and refraction is taking place from here. It cannot be like that. If a ray of light comes and strikes here, from that point only the refraction also should take place. Then if you draw a normal at that point, all the three, incident ray, the normal and the refracted ray, all of them will lie in one plane. The second law, it says like this: the ratio of the sine of the angle of incidence to the sine of the angle of refraction is always constant between a particular pair of media. This we call it as second law of refraction, or we can even call it as Snell's law. This ratio, sin I and sin R, always will be constant, and it is given as the constant term is given as the relative refractive index. If I take this example from denser to rarer medium, then it will be refractive index of first medium with respect to second. Light ray is ending up here. BC is the refracted ray. So medium 1 with respect to medium 2. It is also known as relative refractive index. Now we will be thinking that what is this sin I by sin r is always constant. The meaning is like this. If I take another ray here, then this will be the angle of incidence. Let me mark it as I dash. And the ray will get refracted this way, suppose, away from the normal. Suppose this is r dash. If I take the ratio of I dash by r dash, the value of this relative refractive index will remain the same. Suppose for this, if you are getting 1.5 for sin I dash by sin r dash, also will give us, formula will remain the same. It will give us 1.5. The value will never change. That is the meaning of the constant term. Some of you may be thinking, how will I measure sin I? In this diagram, there is no right angle triangle. So what we have to do is, we will have to draw. This normal will extend it. This normal also will extend it. Take say around 2 cm this side. Then here suppose this is 2 cm. After that, if you draw one perpendicular line here, making an angle of 90 degree and go towards this incident ray, then you get a right triangle. Then you can use your formula sin I. The definition sin I is defined as perpendicular by hypotenuse. Angle is I here, perpendicular is AD, hypotenuse is AB. Then you can measure the value of sin I. Likewise, in this refracted ray also, this distance, if you take 2 cm on the normal, here also you will take 2 cm, around 2 cm exactly you will take it, and draw one perpendicular line here. Make an angle of 90 degree and go ahead. Where this ray comes and meets, there you get a right angled triangle. After getting the right angled triangle, your point C will be somewhere away. This side it will be. There you can find out this is R. So sin R will be perpendicular by hypotenuse. Then it will be from this point. Suppose if I mark it as D dash C divided by BC. Then you can get the value of sin R. After that you can calculate it. Then this value, somewhat say 1.5 came out. Then if you take for the same pair of media, different angle of incidence and different angle of refraction, if you do it again, you will get the same answer, that is 1.5. It's just an approximation value, but it will remain the same. That is your Snell's law of refraction. Hope it is clear. Now let us discuss about the refractive index. This refractive index, what does it mean? Let us see now. Refractive index are also of two types. When we say absolute refractive index, when we talk about absolute refractive index, it is the refractive index of only one medium. Say this is absolute refractive index, we write like this, mu. This is the speed of light in vacuum. We write the C divided by speed of light in the medium. We write it as V. So this ratio gives us the absolute refractive index of a medium. Now, this absolute refractive index you can write like this in general, or most of the time you can see one thing here like glass, say mu G. Then you should understand that this is absolute refractive index of glass alone, only for one medium. Then here speed of light in vacuum, it will remain constant. And speed of light in vacuum, as you all know, 3 to the power 8 meter per second. This will remain fixed. Whereas the denominator term, the speed of light in the medium. Now the medium is what? Glass. So it will be speed of light in glass. The medium is glass. Later we will write V, but you should understand that it should be speed of light in glass. That is your absolute refractive index. Now when you talk about relative refractive index, then you can get here two things like this. This is refractive index of one medium with respect to second medium. Suppose here G indicates glass and A indicates air. Then you read like this: refractive index of glass with respect to air. This is the way you read, and you write this as refractive index of glass is absolute refractive index individually divided by refractive index of air. So how you read? Refractive index of glass with respect to air, that is equal to refractive index of glass divided by refractive index of air. And as refractive index and speed or velocity, they are inversely proportional to each other. This one you can even write it as speed of light in air divided by speed of light in glass. And this refractive index we call it as relative refractive index. That is refractive index of one medium with respect to another medium. So you can remember this way also, like refractive index. What actually refractive index tells us is, it tells us about the speed of light in a particular medium. Refractive index of air, we know that it is 1. Refractive index of glass, it is 1.5. Refractive index of glass, it is 1.5. Refractive index of water, it is nearly 1.3. So these three values, if you can remember, you can keep in mind very nicely. When refractive index is more, the speed of light is to be less. Look here, refractive index of glass and speed of glass is down there. They are inversely proportional to each other. So if the refractive index is less, then the speed of light is more in that medium. Now by looking at the refractive index, you can make out where the speed of light will be more and where the speed of light will be less. If the refractive index is high, then the speed of light is less. And speed of light is less, then it is denser medium. Speed of light is more because refractive index is less. So speed of light in air, it is more than the speed of light in glass. Like that you can compare which is denser, which is rarer. Glass and water, if you compare, water is rarer, glass is denser. When you compare air and water, air is rarer, water is denser. Like that you can correlate with each other and keep in mind. Thank you for today. Hope all of you have understood. We'll see you in the next video. Stay tuned with LFI Educates.